Hello there, Narek is here. Today I'm gonna talk about the addition and subtraction of vectors plus the properties related to the sum or subtraction of vectors. Now, previously I had done a certain video where I was talking about the definition of vectors, where I was talking also about the position between two vectors, and finally the translation of a vector. So you can simply check that video and you will be able to continue directly the discourse. So how do we add two vectors? We have two types of addition. They can be considered as one, but we are usually defining as two types of addition. Now we have the first type is when you have a certain vector AB plus BC, let's say. Whenever the addition of the two vectors that you have are two consecutive vectors, what do I mean by consecutive? It's very simple. It means that the first vector has its terminal point B, the second vector has its initial point B, so these vectors are considered as consecutive vectors. The result will be AC. Now, AB plus BC is equal to AC. It could be considered as the triangle law, or Chasles law. Chasles is actually the name of a French mathematician who discovered this law related to the addition of two vectors. So AB plus BC is equal to AC. We have in the previous video I already mentioned that vectors are related to displacement. So how do we represent AB plus BC? Let's say this is our vector AB, and this is our vector BC. AB plus BC, it means that I start from the initial point A, I will reach to the point B, and then from point B I will have to reach to the point C. So going from A to B, from B to C, it's as if going directly from A to C. So it's as if I'm moving from A to C. That's why AB plus BC is equal to AC. In this case, you have to check the sum of your vectors should be consecutive vectors. So I'm going to write down, this is the addition of consecutive vectors. You simply use the triangle law, or some others simply call it Chasles law. Now, what about the second type of addition? The second type is when I have AB plus AC. As you can see, I do not have consecutive vectors. I have two vectors with the same origin A. So AB plus AC, the addition of two vectors having the same origin. What will the resultant be? It's a vector called AD, such that D is the fourth vertex of your parallelogram. So in this case, in order to be able to do this addition of two vectors having the same origin, you simply have to complete your parallelogram. Now, how do we complete the parallelogram? Again, it's very easy. I'm going to take my two vectors, AB and AC. So this is AB and this is AC. So AB plus AC, in order to obtain the resultant of this addition, you complete your parallelogram. So the sum will give you this final vector, which is AD. You complete your parallelogram, and D will be the fourth vertex of your parallelogram, which is in this case ACDB. All right. So for this case, it's an addition of vectors having the same origin. Now, is it possible to use the triangular law or the Chasles law in this case? Of course. How am I supposed to do this addition? I'm going to take again AB plus AC. So AB plus AC. This was AB and this is AC, and I'm interested in the resultant of this addition. Instead of doing this sum, you can simply do the translation of a certain vector. Let's say the vector AC or the vector AB. I'm going to do the translation of the vector AC at the point B. I will do the translation of the vector AC. What do I mean by translation? It means that I'm sliding my vector without changing the direction or the sense or even the magnitude. So at the point B, I will do the same thing as AC, and I'm going to call the terminal point D. So AB plus AC will be converted to AB plus BD, which is the addition of two consecutive vectors. So I'm going to use a triangular law. So the resultant will be AD. Again, what does D represent? D represents the fourth vertex of the parallelogram ACDB. So in this case, it's again, we have a parallelogram ACDB. So what is the general form of an addition of two vectors? In case you didn't have the addition of two consecutive vectors or having the same origin, you simply choose to do a translation. So I'm going to take the general form. Let's say we have AB plus CD. In this case, this is AB and this is CD. I do not have two consecutive vectors, the addition of two consecutive vectors, nor do I have the addition of two vectors having the same origin. So I will simply choose to do a translation of the vector AB. In this case, I'm going to do the translation of AB at the point D. So at point D, I will have to draw the same thing as the vector AB. So D will take the place of A, and let's say this is the point H. DH will be equal to AB. DH is a translation of AB at point D. So instead of writing AB plus CD, I can simply say that it's AB. Instead of AB, it will be DH plus CD, which is the same thing as CD plus DH, which is CH. Now, what if you chose to do the translation of CD? Instead of doing the translation of AB, probably you're choosing to do the translation of CD. Again, very simple. At the point B, I'm going to do the translation of CD. As you can see, I will reach to a point, I'm going to call it J. So this addition will be equal to AB plus BJ, sorry. So it will be equal to AJ. Now this is the vector AJ, and this is the vector CH. If you pay a close attention to vector CH and vector AJ, they are both equal because one of them is a translation of the other. So whatever route or whatever path you're choosing to do your sum of two vectors, of two general vectors, you're gonna use either two consecutive vectors or the addition of two vectors having the same origin, and you're gonna reach to the same result. So this was the general form. Now, what are the properties related to the addition of vectors? When you have, let's say, all right, U vector plus V vector. U could be the vector AB, V could be the vector CD. So you can simply use one letter instead of AB. It's a form of representing the vector AB. It's a form of representing the vector CD. So U plus V is the same thing as V plus U. This is the this means that this addition is commutative. Now, what about U plus V plus W? You can write it down as U plus V between parentheses plus W. So this relation, or this property is also it could be useful. Now, what about U plus zero vector or vector null? It's a vector which is represented by a point. It has its direction and magnitude, its direction and sense are not defined. The magnitude is zero. So U vector plus zero vector is simply U vector. Now what about U vector minus U vector? It's simply zero vector. All right, so these are the properties related to the addition or subtraction of vectors. Now, in order to understand the subtraction of vectors, you simply need the idea of the addition, since subtraction is the same thing as addition. Let's say I have the vector AB minus CB. So AB minus CB is equal to AB plus BC. You simply use the triangle law or Chasles law, it will give you AC. Now what if I had AB minus BC? So you will have AB plus CB. Now in this case, you do not have the addition of two vectors having the same origin or two consecutive vectors. Now, in order to understand what is happening in this case, this is AB, and this is the vector BC. What do I mean by AB minus BC? AB minus BC, so at the point B, I can write down, I can do the opposite of BC. Minus BC, it means that it's the opposite of BC, so it will be the opposite of BC, which is the same thing as CB. I can say that it's the point D, so it will be equal to AB plus BD, which is equal to, again, AD. You have the addition of two consecutive vectors. So the subtraction is simply the same thing, almost the same thing as the addition. You simply have to switch the negative sign. In order to switch the negative sign, you have to switch the letters also. Instead of minus BC, you write down CB. Instead of minus CB, you write down BC. And geometrically, you choose the opposite of the vector in question. So yeah, that's all for the addition and subtraction of vectors. I hope it was helpful. So why not subscribe to my channel? You'll be notified whenever I upload new videos. I can also share with you my Instagram and Facebook account in case you want to contact me, or you can simply leave a comment below. And I hope it was helpful. See you next time.